Hello and welcome back to another video in Algebra 1 Credit 8. Today we'll be continuing on with factoring. Today we're going to be going over factoring by grouping. Again, if there's any questions or comments or concerns, please come into the Learning Center and visit your tutor or teacher for more instruction, but hopefully this will be enough to help you through the assignment in your Algebra 1 Credit 8 packet. So today we're going to be factoring by grouping. So what do we notice about the problems that we're going to be facing today? So first of all, I noticed there's about 1, 2, 3, 4 terms or 4 pieces in this polynomial. Okay, and the question then becomes, let's look at each of these pieces. Remember, we learned how to factor using the big X and X box. That was this thing here. And the last credit. And we also learned how to kind of factor a GCF, or greatest common factor. Now, but if you notice, there's not really a greatest common factor here. This has an A, that has an A, that has an A, but 15 does not. And this is a multiple of 2. Multiple just means M-U-L-T, I'm putting multiple. That's a multiple of 3, multiple of 2, and 4, and 5, and 10, and that's a multiple of 3, and 5, but none of them are all a multiple of like the same number. So we're going to take out a GCF from pairs of terms. So let me just erase what we just kind of went over today, which was draw multiples. They don't have a multiple in common. They don't have a variable in common. So what we're going to do is we're going to pair up some things and see what we can take out Okay, so about these two. What could I take out of each? Well, I see that they're both multiples of 3, right? 3 times 4, 3 times 3. And they both have an A in common, so I can take out a 3A. Now, if I do that, what would I be left over here? Hopefully you don't need to do this intermediate step anymore, but I'm going to just do this just in case you guys forgot. So if I divide 3 goes into 12, how many times? And then if I take out 1A, what I'll be left over here with? 4A. Again, if I divide out a 3 here and an A here, that'll cancel. 3 goes into negative 9 how many times? Awesome. And then here, I'm going to still have that plus symbol here just because I'm going to do the same thing for this. Okay, so what can I divide out of 20 and 15? 5, right? And so if I divide out a 20 from here, if I divide out a 5 from here, 5 goes into 20 how many times? 4, okay, and then if I divide a 5 out of here, 5 goes into negative 15 how many times? Negative 3 times. Ooh, do you notice anything that they have in common now? Yeah, they have a binomial in common. They have 4a minus 3 and a 4a minus 3. So if I take that out, I have 4a minus 3. I took that out of here and I took that out of here. What was I left over with? 3a plus 5. So that's what we're going to be practicing today. I might have us do a second part if I go a little bit over the 15 minutes. But hopefully I'll be able to wrap this up and provide you instruction for this unit. So let's look at this one. I have 9x to the third power plus 18x squared plus x plus 2. Now again, when I can't take a GCF out of everything, that means I can't take an x out of everything that doesn't have an x. I can't really take a 2 out of everything. That's not a multiple of 2. And I can't take a multiple of 3 out. These might be multiples of 3, but not the 2, right? So here's what I'm going to do. I'm going to take out GCFs from the pairs of terms. So I'm going to pair these two guys up, and I'm going to go ahead and take a GCF out. Now notice that they are in descending order. I'm just going to write that down, descending order by degree. So it goes x to the third, x squared, x, and then just a plain old number. So if your problem that you're doing for homework is not in that order, you might want to do that first. But the ones that we're working on today, they're like that. So what could I take out of both 9 and 18? What's the biggest number you can think of? And what's the largest amount of variables we could take out? A 9, x squared, right? Because 9 goes into 9, 8 and 9 can go into 18, and x squared is the most amount we could take out. So let's go ahead and do that. So if I take out a 9 x squared, 9 goes into 9 once. How many x squareds will I be left over with? One of them. If I do the same thing, if I go 9x squared, well, that'll just cancel out. 9 goes into 18 how many times? It's 2. Okay, so let's do the same thing here. What multiple do they have in common? I know they don't have an x in common, but they both are have a multiple. For example, I'll give you a hint. How many x's do I have here? I have a 1x, don't I? I have a 1x. So what are they both a multiple of? Hint, hint. Oh. Yeah, they're both a multiple of 1. So if I actually divide by 1, I'll just be left with x. And if I divide by 1, I'll be just left with positive 2. Now, why did I do that? So that I could see that they do have a binomial in common here. They have an x plus 2 binomial in common. So I can take out that binomial that they have in common, x plus 2, and what am I left over with? Well, left over with that and that. I'm left over with 9x squared plus 1. All right, so let's go on to the next one. Again, make sure that your problem is in descending order based on degree. In this case, b to the third, b squared, b, and then just a number at the end. So let's look at these two first. What are these both a multiple of? Okay, 2, and what about how many b's can I take out? B squared, right? They're both multiples of 2, they're both even numbers, and I can take a b squared out of both. So let's go ahead and do that. If I divide by 2, b squared, 2 goes into 6, and I'll be left with how many b's? That's 3b. If I do the same thing here, divide by 2b squared, b squareds cancel out, 2 goes into 8. Awesome. Okay, now what about these two? What are they both a multiple of? 3, right? So if I divide this by 3, what will I get? 3b, right? And if I divide that by 3, I should get a 4, right? All right, so do you see a binomial that they have in common now? Yeah, they do. They have a 3b plus 4 and a 3b plus 4. So I can take out that 3b plus 4, and what am I left over with? 2b squared plus 3. All right, we're going to continue on and do as many as we can before my 15 minutes are up. So again, you want to check to see if this is in descending order. Is it? By degree, is what I mean. Is it in descending order? Great. Okay, let's pair some stuff up. So what are these two a multiple of? And how many x's can I take out of each? They're both a multiple of 3. I can divide by 3, and I can take about an x squared out of both. So I'll go ahead and do that for the first one. divide by 3, x squared. 3 goes into 3 once, and if I take out an x squared, if I divide that out, I'm left with an x, or 1x. If I do the same thing here, I divide out a 3x squared, well, that's just going to cancel. 3 goes into negative 15. How many times? Negative 5 times. All right, let's do the same thing over here. What's a multiple I can take out of both? Okay, so 2 I can divide, because they're both even, right? I can divide by 2. So let's do that for the first one. If I divide by 2, what will I be left with? An x, good. And if I divide by 2, what will I be left with here? Negative 5, right? All right, so let's take out the binomial. Let's factor out the binomial they now share, x minus 5. So we're going to do that. So I take out the x minus 5, and I'm left with x squared plus 2. Let's move on to another one. Again, is this in descending order? You always want to check that. If it's not, you want to put that in order. It might mean you need to rewrite the actual question, and that's okay. So let's pair them up. What are these both a multiple of? Well, they're not both a multiple of 2 because this is not an even number. But if you know your other times tables, you'll know what they're both a multiple of. 3x squared, good. So we're going to divide each term by 3x squared. 3 goes into 21. Okay, 7, great. And then 3 goes into 12. Plus 4, good. All right, let's do the same thing over here. And what are these two a multiple of? 2, right, because they're both even. Even numbers are divisible by 2. So if I divide that by 2, what would that be? Great. If I divide that by 2, what would that be? Awesome. Okay, so now we can divide out that binomial that they now share. They share that and that. So I'll factor that out. I have 7x plus 4 times 3x squared plus 2. All right, let's wrap this up with one more problem. I might have to do another video, but just to give you as much practice as possible. So again, we're going to try this one out. We're going to pair them up. All right, what are these both a multiple of? 10, right? 10 can go into 40 and 10 can go into 50. So I'm going to try that out. So 10 goes into 40 how many times? All right, and I'm left with 1x because I only took out an x squared. And 10 goes into 50 how many times? And the x squareds cancel out. I'm left with negative 5. All right. What's a multiple I can take out of these two? Right, they're both multiples of 3. So 3 divided by 12 is 4x. All right. And 3 divided by 15 is negative 5. All right, so again, I'm going to factor out the binomial that they share now, 4x minus 5. Factor that out. All right. And what's left over? 10x squared plus 3. All right. We have a few more that I want to kind of go over just in case we have to move around. So let's try and do this rather quickly. So you might need to move some things around to take out the GCF out of these pairs. So let's put it in descending order. So 4r to the third would go first. The r squared would go second. 24r and then 6. And then you would want to do that same process. So I just want to give you a little bit of practice. So I'm going to go through this rather quickly, and then I'll go for a few more in the next video. So what can I take out of both of these? R squared, and I'm left with 4r. I'm left with 1. Out of these two, I can take out a 6 because they're both multiples of 6. 6 goes into 24 4 times, and 6 goes into 6 once. I can take out the binomials here. 4r plus 1 and r squared plus 6. We'll continue on in the next video, and as always, happy problem solving.